Last week we were discussing on the measures of central tendency, right? The measures of central tendency. The measure of central tendency. And we discussed about some of their formulas, okay? The mean, mode, and the median, okay? We discussed how you can apply them for a grouped data and for an ungrouped data, all right? Now, this is specifically, you know, Jamb class, so there are some things within that scope, okay, that I won't really touch, okay? If it is for maybe other classes, I will touch some aspects. But seeing the fact that the JAM syllabus covers some areas in these topics, okay, so it won't be quite okay for us to just cover things that we will not be able to face, that will not face in the exam, so we don't waste time. All right. So we discussed that under this measure of central tendency, we have the mean, mode, and the median. Okay, and we explain their formula for the ungrouped data, right? Then you also explain it for the grouped data. And I kind of explained that the group data is divided into two, where the data given you can be in the form of what? Non-interval, and it can be an interval. Okay, so I explained the mean. For the interval method, I'm not really going to touch the non-interval aspect. Okay, the only thing I'm going to touch is the interval aspect, because for the interval aspect, okay, I won't touch this, but I will touch this. Okay, I won't really touch the interval. I'm just going to touch the non-interval. All right. So for the non-interval, we still have our mean, mode, and median, and we discussed that x bar is summation fx over summation f, right? Good. Okay. So don't worry for your jam. You don't really need the interval aspect. Okay. But for the non-interval, okay, it's still grouped. So you are going to touch the mean, which is summation fx over summation f, and I explained that last week, and I did an example. And for the mode, okay, you just have to pick the number with the highest frequency. And for the median, you just have to know whether it is mean, whether your data is even or odd. Then you know what to apply. Okay. Now, so I believe that's all for the measure of central tendency. Okay. So let's move on to the measures of deviation. Measures of deviation. Okay, and under the measures of deviation, we are having just four things here. One, we have the range. Two, we have standard deviation. We have the variance. Then you have the mean deviation. Mean deviation. Okay, so for the measures of deviation, what measures of deviation is just explaining? Okay, we have measure of central tendency, and that talks about mean, mode, and median. Now, I use this concept to explain these topics in the sense that anytime we are talking of measure of central tendency, it is just looking at things that are attractive. Okay, it places more emphasis on things that are very, very what attractive. For example, you go to a place and somebody wears and somebody wears a clothes, okay, and that clothes is very, very attractive, making that person to be known or making that person to be noticeable. Are you getting it now? Now, anything that try to make someone noticeable or It's as a result of your characteristics, you are being noticed in a particular place or area. That means what is at play in that place currently is what the measure of central tendency. Are you okay now? But when we are trying to explain for the measures of deviation, okay, the measures of deviation is just looking at how data are spread. They are spread away from the mean. Okay, for example, look at this. Let's say I have a data like this, where I have this center here to be my what? My average. And you know, mean is average, right? Let's say I have the data straight like this. This is the data straight, right? And this is the what? The mean. Okay. Now you observe that this data spread has a particular distance from the mean. And this data, you know, this is the to me, it is the left hand side, and this is the what? Right hand side, right? So if you look at this from the left hand side, okay, there is a level of distance for which this data is separated from the mean. And from the right hand side, there is a level of distance for which it's separated from the mean. So this variation here, okay, that's what you call what? The measures of deviation. Are you following now? So this is what we measure. Anytime we are looking at the measures of deviation, we are looking at how the data is spread away from the mean. That's why if you want to solve for the measure of deviation, almost all these things here, they have what you call the mean inside. The mean is inside all the formula, apart from range. Do you get it? Because it's looking at how data, are spread away from the mean. Now, let me give you an example, a practical example. Now, let's say you are producing a particular item. Okay, maybe you are producing books. Okay, let me not use books. Let me use something. Books is okay. Oh. Let's use books. Books. Now, when you are selling books, are you getting it out? There will be a particular book that you sell, okay, that brings you more income. Now, let's say you are in the educative area or educational area where you are producing mass textbooks, you are producing mass textbooks, you know, English, anything related to school. Now, let's now assume that out of all those books, the mathematics textbook you are producing, okay, has now become your average. Or better still, it has become your mode. Let's say it is your mode now, in this sense. The mode. Now, when we say it is the mode, that means it is the one that is being sold at the highest rate. Now, let's just say the mathematics is being sold at the highest rate. Now, after this, there will be another book that is closer to that of math. Are you getting it? And since there's another book closer to that of math, let's say another book that is closer in sales to that of math, let's say it is what? Economics. Are you following now? That means that there is a distance or there is a variation between the amount of mathematics and the amount of what? Economics. That is the amount of the sales you made from math and the amount of sales you made from what? Economics. So that difference is called the what? The variation. You see it now? Or you call it what? The deviation. Are you following? So it's not only how it goes away from what? From the mean, but how it goes away from the what? From the central tendency. And most of the time, the central tendency, the area of emphasis that we look at is the what? Is the mean. Okay? Good. All right. So when we are looking at measures of deviation, this is all what we are talking about. So let's take their formulas. Let's take their formulas. So we take range. For range, this is the highest value, okay? The highest value of the data set minus the lowest value, okay? So I can just call it HV minus LV. You see it now? So this is what you mean by range, okay? Range. Then you move on to standard deviation. Standard deviation, that is square roots. Now, the thing is, you need to understand something here because we have two types of classification of data, where data can be classified as groups or ungroups. So let's deal with ungroups first. Okay, all right. So for the ungroup, we are just going to say the square root of summation, all right, open brackets, x minus x bar, square it all over n. Okay, so this is for the standard deviation. Then you move to variance. Don't forget that for ungroups, there's no frequency. So for the variance is just when you square your standard deviation, you get your variance. Okay, when you square the standard deviation, you get variance. So that means that when I square this guy, what happens? The square root disappears. So what I have here is summation open brackets. You observe that the mean is there. The mean is there. You can see over n. You see it now. So from the standard deviation, variance, and mean deviation, the mean is there. Are you following it now? Now let's move on to mean deviation itself. So for my mean deviation, that is just telling us the summation, then absolute value. Okay, summation of my absolute value, x minus x bar, then all over n. That's all. Okay, so these are the measures of deviation for what? For the ungrouped data. So without wasting much of our time, let's just take an example. Given the data below, so I have this data 1, 2, 2, 3, 5, 3, 4. So I have this data below. Calculate I, the range, I, standard deviation, I, variance, IV, mean deviation. All right. So let's see how to solve this example using these formulas. So for range, solution, range. So my range has what? The highest value minus the lowest value. So I just come here and say HB minus LB, right? So we have HB minus LV. So if you look at my HB minus LV, what's my highest value here? You observe that my highest value is what? Is 4. And what's the lowest value? 1. So what do? Just say 4 minus 1. And what's my final answer? 3. And that's all. Okay? So that means that the range is just the highest value minus the lowest value. It's as simple as that. All right. So that is my range. Okay. Then we move to number 2. And for my number 2, we have what? The Roman figure 2. Okay. We want to solve for standard deviation, right? And standard deviation, I have SD right here. So let's look up the formula for standard deviation. The formula for standard deviation is the square root of summation x minus x bar. You square, then you divide by what? By n. Now, look at the data I have. Now, for the data, Okay, there is a way you can actually make this thing to be very, very simple. So look at your data here. One, two, two, three, four, right? So that means that this summation, okay, you all know that summation just means to add up. And look at this. This is my x. Now, this x here just stands for the observation. That is each element in your data set. That is your x. So if you look at this is x. This is another x. Okay, this x. So I can, for clarification, I can say x1, x2, x3, x4, x5. Okay, because these are my x values. They are more like observation. Okay, all right. Then the only thing missing here now is what? X bar. And X bar stands for what? Your mean. So that means that if you observe, this summation means to add up, but X here is given. X bar is not given. So what do? You look for X bar yourself. N is given. What is your N? Your N is the what? Is the number in your data. Oh yeah, so how many numbers do I have there? One, two, three, four, five. So N is given. So what I need now is my what? My X bar. So that therefore, let me write my formula out first. So standard deviation equals to square root of summation open bracket x minus x bar all squared over n. So I'm looking for x bar now, which is my mean. So the formula for mean, don't forget we are dealing with on group, which is summation x over n, right? So let's deal with this one. So let's get our, what do we call it now? The x bar, which is the mean. So summation x. So that means that summation x, that is add all your x values, right? So let's add them. 1 plus 2 should give me 3. 3 plus 2, that's 5. 5 plus 3, that's 8. Then 8 plus 4 is 12. So that means I'll be having 12 over 5. And that will give us 12 divided by 5. I think I should have 2.4. Okay, 2.4. So that means that my x bar is 2.4. Okay, so now we have gotten the x bar. Okay, the x bar being 2.4. So now what do we do next? We now approach and get the what? The standard deviation. So in solving your standard deviation, okay, what I just do is I just create a very small table, very small mini table, very small. Just write this thing here. So you just come here and say your x values, right? So what are your x values? One, two, two, two. Okay, 3, 4, right? So these are my x values. Then what's the next thing I need? I need x minus x bar, right? So I just come to the next this thing. I say x minus what? X bar. Okay. All right. So what is my x bar? So let's get our calculators ready there. So now, you know that I have my x bar to be 2.4, right? And I have my x to be 1. So I just say x minus x bar, that is 1 minus 2.4. Okay? So I believe 1 minus 2.4, that will give me minus 1.4. Okay. So the next thing, 2 minus 2.4, and that will give us minus 0.4. Then this one, 2 minus 2.4 again, minus 0.4. Then 3 minus 2.4. 3 minus 2.4. And that is 0.6. Then 4 minus 2.4. And that is 1.6. So you see now we've gotten your x minus what? X bar. So what's the next thing we do? We square it, right? You know, that's the formula. X minus x bar all squared. So we just come here and we square it. X minus x bar all squared. Okay? So we just come here and we square the answers here. So I just come. Now, if you are squaring, or if you want to square, you know that when you square a negative figure, you get positive. So you don't need to punch in your minus anymore. Just write 1.4 and square the man. So when you square it, you get 1.96. Okay, 0.4. You square the man, you get 0.16. This one 0.16. I believe this one too should be 0.36. Okay, then 1.6. You square it, and we have 2.16. You see, that's very simple. So once you have done this, hello, x minus x bar all squared. What do you do next? Summation. Sum the, you don't need this guy again. What you just need is sum this guy up. So let us sum up. So 1.96 plus 0.16 plus 0.16 plus again 0.36, then plus 2.56. All right. So I'm having 5.2. 5.2. So now I just go back to my formula, right? So therefore, standard deviation equals to, so everything in the numerator is 5.2 divided by, what's my n? My n is 5. Okay? So the next thing we do here is just divide 5.2 divided by 5. And we are getting 1.04. Okay? So final answer, the square root of your final answer, that is the square root of 1.04. And that is 1.01. Okay? And that is our final answer for standard deviation. It's as simple as that. Okay? So you are done with this. Then you move on to the next this thing, which is what? Variance. 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 So how do you solve for variance? I told you that when you square your standard deviation, you get your variance, right? So this is my standard deviation right here. So when I square it, it means the square root disappears. So I just have summation s minus x bar all squared divided by n. Already, we've gotten this already. Okay? So you observe that your x minus x bar square, this is the answer here. Where do I have it here? I think from here, okay. Everything here is what? 5.2. So I just come here and say 5.2. Then I will divide by what? By 5. Then final answer is what? 1.04. You see, very simple. So you are done. Okay? You are done. Then the last one, mean deviation, IV. Mean deviation. So how do you solve for mean deviation? For mean deviation is very simple. The formula is summation. So let me just call it n, then the d will be under as a subscript equals to summation absolute value x minus x bar then over n. Now this is very simple, okay? Now what do you mean? They said absolute value x minus x bar. You know I've done x minus x bar somewhere here, right? So what I just need to do is what? I just need to take up their what? Their absolute values. So I come here. Absolute value x minus x bar. So that means that for absolute value, the absolute value of a negative number becomes a what? A positive number. So if this is minus 1.4, I will get what? 1.4. Minus 0.4, 0.4. Minus 0.4 again, 0.4. But when you get to plus, you know this is plus 0.6. Now, the absolute value of a positive number is still what? A positive number. So what you do is what? You just say 0.6. Okay? Then the last one, 1.6. Then what do you do? From the formula, summation. Add everything together. So let us add. So we're having 1.4 plus 0.4 plus another 0.4 plus 0.6 plus 1.6.